So we're going to try to do GitHub, show you my battle game server that I've written. This is live now on, if you go to battlegameserver.com. This is the live server that you're going to be connecting to with our Battleship Android client. And so the idea is that we're going to build a client on our Android device that lets you maneuver ships around and place your ships and do a turn-by-turn based game. Each turn will be sent up to the server and broadcast down to the other person. So you have two people playing through the server. Does that make sense? So this is the idea to start with. And some of this is not working yet, but it's got enough to get you started. So the first thing we need to do is to show how to log in. So I wanted to show you, I've got the API worked out here. You can see the official rules for Battleship here from Hasbro. And these are how we're going to make a call to the server. So we're going to call /API/v1/ and then login, for instance. So if I use a login, we're going to use what they call basic authentication because that's easiest to implement right now. What that means is it takes our username and password as a hash and sends it as a header in the request. So when I log in, I'm going to get this information back as a JSON object. This is an example of this person's information. So I get a first and last name, their avatar name, the level and coins and battles and experience and everything they have, email address, as well as their particular avatar image, which in my case would be this little guy here. So we're going to try that first, and then I have several other APIs that are, some of them are working, but we'll fix them as we go through. And here are some of the tables that I have on the server side. So we're going to have a board. You're going to have two different boards. You can have an attacking board and a defending board, just like in the real Battleship game. And then we'll go through a turn-by-turn based system. All right. So the first thing we have to do is send our username and password along in a request to the server. And this is surprisingly complicated. I would have thought that after 15 versions of Android that they would have had this down by now, but it's a little bit painful to get this to work right. So I'm going to show you the long way to do it first, and then we will show you a shortcut. But the reason I'm going to go through the long one is because it teaches several things about Java programming and callbacks and things like that that are useful information. All right. So what I want to do is I've already created a form here with a username and password. That's all I need to log in, and then a login button. And my login button, I need to have go to a login to server method. So that should all be straightforward. I'll go to my main activity here. And we need to start working on this. Now, the way that Android allows this, let me show you the official Android way of making a connection. Is called an async task. So if we look at this async task, this is how you have to create a process. Now, it was a couple versions ago of Android that they decided that they did not want anybody to make a request to a server on the main thread, the UI, what they call the UI thread. The UI thread is that was handling our button presses and our typing and all that kind of stuff. They wanted, because apparently that was getting bogged down, if you make a request in that thread, the user interface looks like it's sluggish, and they didn't want their user interface to be sluggish. So now they don't allow you to do that at all. You have to make a separate thread. So do you guys know what a thread is? Everybody know what a thread is? Mostly. So basically a thread is just another process. So we have our main UI thread, which is the main code that's running in our activity. And then we can, what they call, spawn additional threads, which are just it's basically like another program running side by side with the main UI thread. And the operating system uses a system of giving each thread a little piece of time of the processor, because the processor can only do one thing at a time. Unless you have multiple processors in a box, it can do one task at a time. It does one instruction at a time, goes to the next instruction, etc. So in a multitasking environment, when you've got multiple processes, it gives a little bit of time to one, it then puts that aside, loads the next thread or process into memory, does a couple of instructions on that one, moves it aside, gets the next one. So it goes through a cycle, and there's different methods of how it decides who gets priority, and etc. And so there's things called a round robin, which it just gives each person the same amount of time. There's all kinds of different ways to prioritize those threads. So basically, we're forking off our process, and we're making a whole other program that's running in parallel to our main UI thread. So it can do things, and it can wait, and it can make a web connection and sit there and wait for 30 seconds to make the connection, and my UI thread is still running. So it doesn't have any problem. When your asynchronous thread finishes, then it kills itself. That thread gets destroyed, and then we just have our main UI thread again. So we need to have ways of passing information to the initial thread, the other process, and then getting that information back into the UI thread. So there's two different things we have to deal with. And that's the problem. So this is what they came up with, a way of doing that. They have this async task that we create, and they have 3 or 4 different methods in this async task that are executed. So the main thread here is done, the main method, the main function is called do in background. And the do in background is the thing that takes the longest. That's the stuff we're going to go out, make a request to the website, download all the data, maybe parse it into a JSON object so that we can play with it in our own Java environment, and then quit. So this can take a long time. We don't care how long this takes because it's running in a separate process. Every once in a while, we can call this progress update, and that allows us to interact with the UI thread. The UI, this function here actually runs on the UI thread. So since it's on the UI thread, I can access things like a progress bar. I could update a progress bar to show that I'm getting more data from the server and it eventually finishes, for instance. So that's one way of communicating back to the main UI thread. Once it's completed, this is also executed on the UI thread. So this one is executed on the new thread, a whole new process, so it cannot communicate directly with the UI thread. But these are executed on the UI thread itself. So it has access to all the IDs of the buttons and the progress bars and things like that. So once it's finished, when this guy finishes, this guy gets executed, this on post execute, and that's where we can then load some UI elements and fill in a list of users or things like that. Okay? So this is the main structure of this task. And these three pieces here, these are called virtual properties of a Java object. Because Java is more or less compiled like C# and C++, etc., you can't do dynamic changes of data while it's running, unlike Ruby. Ruby just makes it so easy. I don't have to worry about changing data in the middle of the field, right? It's really easy to do. So what I have to do is I have to pass three types of data. These are types. So this is an integer type, a long type. The first one goes to what is passed into the do-in background. So this is actually a shortcut for an array of URLs. A bunch of URLs gets passed into this. An integer gets passed. I'm defining that the async task gets an integer on this progress update. So it gets an array of a bunch of integers. Then my long result goes into my post execute. So those are the three things that I pass into my async task, and those data, that data is what gets passed into this information. So the URL is really the first thing I pass into my site. It goes into my do-in background as a parameter, and I can go and make a request to that URL, right? Then it returns a total size. That total size is what gets passed to this on post execute. Very complicated. I'm telling you, to get this to work, it took me 2 days. And to understand it. So let's try and write some of this. So we're going to have a new class. We're going to call it, it's going to be a private, private class, and I'm going to call it get JSON async. Where'd it go? And it has to extend, which means what? What does extend mean? That tells who its parent class is, right? So it inherits all of the data from the parent class. It gets all of those methods from this async task. And then we have to tell it what are we going to pass in and out of this information. So we're going to pass in some information. So we might pass in like a URL, an integer, and I'm going to fix those up in a minute. I just want to lay out the structure here to start with. And we need to have, there's a method that we could call that wasn't in the documentation. It's called protected, oops. It's 9 o'clock, by the way. Void on pre-execute. And for now, we're just going to call the super.on pre-execute. So that gets executed when do you think? Before it starts, right? So that would be a good place to set up some things that I needed for making this HTTP request. Then the main workhorse of this guy is my do-in background. So I'm going to have a method. I'm going to put these in here because I don't have it any other way right now. And I guess this should be an integer. And we'll define that server request in a minute. So this is the main code. It's going to return a server request, which is an object that I'm going to create here in a minute. And the do-in background is the main workhorse. and it's going to do some stuff. And at the end, it's going to return some type of a server request. Okay? Then, and I'm going to fill in the code here in a minute because there's a lot of it. We can also have this method called progress update, so that if this is a really long process, we could have this like fill in a progress bar, something like that. So I need an on progress update, and it takes an integer. It takes an integer here because of this parameter here. I could make this take a string if I wanted to. And what it does is, inside of this do in background, I can call this on progress update, and it will call this with some values. So I'm going to use an integer so I can say I'm 25% done, I'm 50% done, etc. And so that's going to do something with our progress bar later on. And then when I'm completely finished, I have this method called onPostExecute. And it's going to take a server request, which I'm going to call SR, because that's what this guy returns. So when this one finishes, it sends the server request object over to my onPostExecute, so that then this one, remember this executes in the UI thread, because there's no crossing of data in the different threads. They're completely separate programs running. So I can pass data into it, I can get data out of it, but the connection between those is difficult. All right, so any questions on this basic structure so far? So let me show you my server request. And I'm actually going to go copy it off of my GitHub account here. It is. So this is my Battleship program so far, and I have this server request.java, so I'm going to copy this data. And for this one, I used my handy dandy Ruby gem to generate all of this code for me, because it's just painful to write all of that stuff, right? So this is, let me copy that and put this into a new file. Oops. A new Java class that we're going to call server request. All right. I don't have my base activity in here either, do I? So let me copy that again. I had base activity. It's a good place to put stuff that all of my activities are going to use. And again, I'm going to copy that off of here so I don't have to retype it in. Got a lot of things I don't have, huh? I need my menu resource. might as well get it now. This is a resource. I need to add a new resource directory. Remember, it's going to be a menu type structure. Oh, it's got it here. Menu. We'll add a new resource file called menu. And we'll paste in my menu. And we'll just fix that up like that. Well, I don't really need these right now, so I'm just going to take them off. All right, so let's go back to my server request and show you what I was meaning by this. What I wanted was a nice way of passing a bunch of information into this asynchronous task method. I wanted to send in things like the URL that I'm going to connect to, and I wanted to get back things like the result code of the request that I get, the actual data that I got back from the user, and potentially some error string that might come back from it as well. So when I create this, I'm creating it. I also send it what I call a command, because the problem, what I started going down this track, the problem is that this is just not a very dry way of doing this. For every request, you have to send it, you have to be very specific on the data you're getting back. So you have to have an async request for the login. You'd have to have an async request to get all the users. You'd have to have an async request, all completely separate, because the do in background is so specific to the data that you're getting back, because that's where you're going to parse the data. So a real pain. It doesn't dry up very well. And so my first attempt was to make this by passing a command. And if you look in my base activity, I have this enumerated type that I created, which would allow me to do different things by passing a different server request in. So a login would do different things than a get the users or a get the avatar method. So that was my attempt at that. And I'll show you there's a better way to do this after I show you all this. But this is the way that most people out there are doing it. They're doing some type of a async request like this. All right? So my server request then had all kinds of getters and setters, right? And my Ruby program generated all those for me. Beautiful, eh? So that's what I'm passing in. That's what is being passed and sent around inside of the async request. And I'm going to set that data up inside of my my login piece here. So I would do something like, I want to create a server request. We'll call it SR. And this creates a new object from this class. And I'm going to use a get users URL. And then I have this server command .get users. And the get users URL was just a string that I created up here. So this battle game server is all written in Rails. So if I go to this request, if I request this site here, with the addition of the .json, I get this JSON data coming back from the server. So this is an array of user objects. All right, very simple. A bunch of user objects. And these have different avatar names and things like that. And this might change a little bit. I might not pass in the email address and things like that to keep that private. But these are how I would populate perhaps a list of users that are available to play. And I could select one to challenge that user, for instance. So that it makes it really easy in Rails to get a JSON object. Now, JSON is just a bunch of arrays and objects that can be easily converted into JavaScript. Its basic structure was built in JavaScript. So this is the object name, and this is its value. The name of the property and the value of the property. That's all that is. A bunch of key value pairs that I can play with.
Can you get that off a site that's not written in Rails?
Only if they allow it. Sure. Yeah. I could write. I could do that in PHP, for instance. I think there's a PHP object to JSON kind of parsing, so it's possible to do that. It's just a format, and this is kind of becoming the web de facto standard in passing information to and from a server. Before it used to be XML, but this is a lot less verbose than XML. I don't think I have an XML. Yeah, okay, so this is the same structure in XML where I have a user object, but see how many more characters it takes to define a name, the property itself, and the value of the property. But it's the same concept. It's an array of a bunch of user objects. So you can see it's just cleaner, easier to parse, less information to pass around. All right, so there's a lot more code to put into this, and we're out of time, but that just shows you the structure of what we have to do. So we will, on this do in background, we're going to actually make an HTTP request. We're going to send it some login information, and I'll show you how to get the data out of these two text fields and create the basic authentication hash that we need to send along with the URL. And we have to send that along with every URL. Remember that HTTP is stateless, right? It has no concept of state. So we have to essentially log in every request. We're sending our credentials with every request to the server. So it knows who I am every time. And the Rails side will look you up automatically. I've got that built into a database, and it'll authenticate you and give you back the data automatically. All right? Any questions on that so far? All right.
Pretty cool stuff, dude.
Pretty cool stuff. All right, so let's stop this for now.